In your last section of Geometry 6.6, we're dealing with trapezoids. So when we were dealing with rhombus, squares, and rectangles, they were all part of a parallelogram, and a parallelogram means that two opposite sides are parallel. Well, this doesn't even fit in any of them. A trapezoid is like a different version of a quadrilateral. Quadrilateral is a four-sided figure. A trapezoid only has one set of parallel lines. So that means one of the sets are parallel and the other set are not parallel. So they don't fall under rectangles, rhombus, squares like we're used to. They're in its own category. So in a trapezoid you have one set of angles, of sides that are parallel. They don't have to be equal, but they are parallel, and the ones that are parallel are called the base, and the ones that are not parallel are called your legs. Okay, we have something called isosceles trapezoid. So if you remember what an isosceles triangle was, an isosceles trapezoid is the same thing but with a quadrilateral. So basically that means that two sides are congruent. So it just means that equal legs. So this means that AD equals BC. So line AD equals BC, and that's what makes it an isosceles trapezoid. And there are certain properties that come with isosceles trapezoid. The first one is Theorem 6.18, which means that if you have an isosceles trapezoid, then the pair of base angles are congruent. And the sets of base angles, basically this is a pair with this base angle, and this is a pair with this. So they're congruent to each other. So this tells me that angle A is equal to angle B, and angle D is equal to angle C. Let me draw that in. Okay, so angle A is equal to angle B, angle D is equal to angle C. Now, Theorem 6.19 is talking about the diagonals, and basically, in an isosceles trapezoid, the diagonals are congruent. So it's telling me that AC, the entire line of AC, is equal to the entire line of BD. And those two are properties of isosceles trapezoid. Then we have a final one, Theorem 6.20, but this can be applied to any trapezoid. So it doesn't have to be applied to just isosceles, but it could be also. And that deals with the median. Okay? Now, median in a trapezoid is different from the one that we were dealing with in triangles. And basically what the median does is that you draw a line right here, and these are the midpoints. So if I take this, E is the midpoint, so this equals to this, and F is the midpoint, so this equals to this. And if you connect the two midpoints of the legs, okay, you get the median, and then you create it so it's parallel to the sides, and that median gives us a special equation. The median is 1/2 the sum of the bases. So if I add up this base and add up this base and I divide it by 2, I get the length of the median, which is EF. And that's an important equation that we're going to be working on. So go ahead and write this down. Do the vocabulary. We've done some of the vocabulary already. Do remember that 6.18 and 6.19 apply to just isosceles trapezoids, but the theorem for the median applies to any trapezoid. And we have one example, and then you're home free. Alright, so this first one, it tells us already that it's an isosceles trapezoid. Remember, you can't just apply properties that you know. It has to tell you, is it a parallelogram, is it a square, is it a trapezoid? This one is telling us that it's an isosceles trapezoid. So we know definitely that ED and FG is equal because of their legs. But they also tell us, and I don't know why it's not written here, but they also tell us that this is a median. Okay? I know I wrote that in, but it's actually in the problem that I just didn't put in there. They tell you this is the median, so that means MN is the median. So with that, those two statements, I can then use the properties that I learned, that you can look in your notes, on how to solve this. The first one is asking us to find DG. Okay? They want us to find DG, and they tell us that EF is 20, right, and MN is 30. Now, just like the other equation, it basically says that the median is half the sum of the bases. So basically, mn is my median equals half of the sum of the bases. My base is EF, okay, plus DG. Okay? So now I'm just going to plug in what I know. I know what EF is, so mn, I know what mn is, which is 30. Okay? I know it's 1/2. I know what EF is, which is 20, but I don't know what DG is, so let's call that X. See how that works? So I figure out the equation, then I plug in what I know to find out what I need to know, and the X is what I need to know. So what I'm going to do is I'm going to take this, and I'm going to get rid of it by multiplying 2 by both sides. So 2 times 30 is 60, and 2 times 1/2 cancels this out, so then I get 20 plus X. What's next? I'm going to divide both sides by 20. I end up with 40 equals X. And I can easily check that. If I add 40 and 20 together, it gives me 60. I divide that by 2, and that gives me 30. So I know for sure that that's correct. And this property right here it's just because it tells me that it's a trapezoid. So even if it told me it's not an isosceles trapezoid, I can still apply this. Now, for this one, it says that find all angles if measure of angle 1 equals 3x plus 5. So 1 is 3x plus 5. And 3 is 6x minus 5. Okay? I know this is an isosceles trapezoid, so what do I know about the bases of the isosceles trapezoid? I know that the pair of bases are equal. So if angle 1 is 3x plus 5, what does angle 2 have to be? It also has to be 3x plus 5. Same thing with the next one here. If this is 6x minus 4, then I have to make this 6x minus 4. 6x minus 5. Because of the fact that it's an isosceles trapezoid. But now I have to find out what each angle is. Before I do that, I need to find what letter, which is X. I know that in any quadrilateral, all the angles add up to 360. Just like a triangle is 180. Remember that equation 180 parentheses n minus 2? So in a quadrilateral, we know that it all adds up to 360. So I can add everything up. 6x minus 5 plus 6x minus 5 plus 3x plus 5 plus 3x plus 5 equals 360. Okay? And I'm going to go ahead and combine like terms to see what I get. 6x plus 6x is 12x, plus 3 is 15x, plus 3 is 18x. Then negative 5 is negative 10. Plus 5 is positive 10. That cancels out, so 18x equals 360, right? Because we get a 0. So we don't have to put that in. So then we're going to do what? Divide. Okay, we're going to divide both sides by 18. And we get x equals 20. Sorry, that's supposed to be 18. Okay, these cancel out. I get x equals 20. Am I done? Not necessarily, because I have to find the measures of each angle. Now, I know that these are equal, so if I find one, I find the other, and then if I find this, I find the other. So I just have to plug it in twice instead of 4 times. So I'm going to plug in x equals 20 to the first equation. 6 times 20 minus 5. This is 120. Minus 5 gives me 115, is measure of angle 3 and 4, and measure of angle 1 and 2 is 3 times 20 plus 5, which gives me 60 plus 5 equals 65. So measure 1 and 2 is 65, and measure 3 and 4 is 115. So go ahead and write those down. Try page 360, number 5 and 6, 360, number 5 and 6, and I will see you in class.